Et donc on va ouvrir
So we're going to open a new sequence on a new theme, a subject that's very important to us all. We talk about it all the day, and that's IA, artificial intelligence, AI even. And for the first presentation, I'm going to ask Mehdi to come and join us up on the screen. It's from the Technical Institute. I'm sure you know him. Mehdi, before being here, was in charge of scientific and digital scopes. So well placed to talk to us about artificial intelligence. So he today is going to talk to us about the risks and the advantages of using intelligence, artificial AI in agriculture. Hello, everybody. A few words then. ACTA, what are we then? We're a structure which coordinates all the different agricultural institutes and organizations. So we represent 19 technical institutes. We're all doing the same job, applied research. We want to acquire and share knowledge in order to offer what? Well, solutions, technical solutions to producers. So in ACTA, we are working beyond coordination, really, in the network. We're also working on some issues which are cross-disciplinary, especially the digital world, of course, which has been part of my remit for some time now, which is why I'm going to talk to you about AI in agriculture, the uses that are already in practice, and other ones which are still currently being developed in order to bring solutions to tomorrow's world. Perhaps I'll give you. Here's a little history of what's been happening. You're all familiar with what's been happening since ChatGPT came to the fore. But it's not really that new. It began to be developed in the 1940s. And I like to show on this fresco the different innovations that were taking place at that time. And this is over the last few decades. If you look at the lower part of the slide, you can see technical innovations in the agricultural world. And you can see a line of progress. And there were all different benchmarks. Look at the 1940s. During the war, there was a great deal of work done by Alan Turing. And he showed that the computing had a huge role to play. Obviously, the decoding of the Enigma machine was paramount in the bringing down of the Nazi regime. This was a time when in agriculture we were looking at tractors, and we needed decades for these developments to be put in place because the technology had been in place for quite some time. So if you look what's happening now, 1956, you've got the term artificial intelligence is defined in Dartmouth. So for 70 years, the term has been around. You have the development of the first combine harvester. It was almost four-wheel drive. You can see it in the 50s. And you can see that in the 60s, then we see the initial work on the chatbots. You think it's recent, but it's not. You can go right back to 1960 and you can see the research was already taking place. And in agriculture, we were looking at what? We were looking at improving the Green Revolution, the first trials on direct seeding. Moving on to the 1970s then, we're talking about the AI winter. There were periods, of course, where research stopped. Very few people were working on the subject. It was less fashionable, I suppose. And then, of course, new discoveries relaunch the work later. But in the 70s, we can see the development of the phytosanitary products, the automated sprayers in 1980s kicks off again. We look at the neural networks, which are really the technology and structure which are necessary to the use of AI. And in farming, where were we? We were looking at the first genetically modified crops and agricultural GPSs that were being developed. So really precision farming. And of course, this was further developed in the 1990s. Again, in the 1990s, this was really when AI became very well known to the public through a major event. It's this famous chess match between the world champion at the time, Kasparov, and a software by AI, by a machine. And of course, Kasparov lost. I think that this is really characterizing the event of the time. One of the greatest minds of the century was beaten by a machine. And I think we were able to witness that the machine in some areas could actually surpass the human. We move into the year 2000. You have deep learning, you see databases, enormous, huge databases. You need a great deal of data sets in order for the tools linked to AI to work, because obviously they use this for deep learning, machine learning. This developed in the early 2000s with fairly remarkable breakthroughs in language. And we see that dripping into the agricultural world with the first decision-making tools developed in the early 2000s. And they also have this capacity to use algorithms and IT tools to interpret images in order to suggest solutions. And you have an example here. FarmStar, this was developed in the early 2000s. They were working with Airbus to try and make the best use of satellite images in order to analyze zones which needed extra fertilization compared to other zones, of course. So you're really looking at decision-making tools which would enhance imagery. In the 2000s, you have research taking place. Well, research was actually just exploding. If you look at the different generational models, or the GAN, this generation of images and language, BERT, is still being used in 2020. The solutions are found 10 years after these tools were initially introduced, of course, but there's constant work being done. And in the agricultural world, there is again an explosion of IoTs, the Internet of Objects, all the sensors connected on board, embedded solutions, which, of course, allow the production of data, which will then in turn nourish and feed into these decision-making tools in IA. And still breakthroughs in 2020 in terms of research. Perhaps you followed the Nobel Prize. It was last year, I believe, to AI researchers from a Google team, who have helped move science forward enormously with this AlphaFold tool, which allows you to predict protein structures using artificial intelligence, which has really, in no small measure, helped research and allowed people to make breakthroughs in this sector and in other sectors, particularly in life science. And ChatGPT, 2022, you had the public version, the earlier version, and this has exploded, obviously. And in the agricultural world, where you saw the pictures this morning, the development of robotics, and we can see this in the plant world. In the animal world, it's slightly older. We had the first sort of milking machines in France a lot earlier, but with plants and crops, the arrival of these first autonomous robots is well underway. So, digital world is a reality.
It's not only a futuristic projection. We are actually as well developed in that matter as other sectors in terms of digital equipment in farms. It is a reality. So more or less controlled. Sometimes agro-equipments are not controlled by the farmers. They can equip farms, parcels, buildings, but the data may be gathered by the service provider to help the farmer to decide on the actions to take. When talking about artificial intelligence, let's start by defining it. I used the traditional definition, although it is being debated by many specialists, because a lot of specialists do not like artificial intelligence. They prefer machine learning. But the word AI has become mainstream, so let's define it. It designates the theory and development of computing systems that are enabled to achieve tasks that are usually only achieved by humans. Visual perception, that's an example. Since the years 2000 and especially the 2010s, machines can actually perceive within images or even videos more accurately, at a more massive level, and at a fastest speed than humans. Vocal recognition, decision-making, writing and reasoning, and so many other things. You can see ... means there are many other things. Every day you can see new things that AI can do that used to be exclusively achieved by humans. It's also different from automation. You can see that in the farming world, you have strongly automated machines. What's different with AI is that AI is not set, it adjusts. It doesn't need to be reset by human beings. It does it itself. It adjusts, it evolves. Robots can actually adjust, evolve, learn based on the field they're working on. AI is a large family. Machine learning, neural networks, deep learning, all these is part of the wide concept of AI that can be used in different tools. So where do we find AI in the agricultural sector? I gave 4 main uses today. First is to support decision-making. We talked about decision-making tools to change your tactics or day-to-day decisions. Should you spray or not? At which date, and so on. And it can be more strategic and tactical as well when simulating projections in longer-term future. Investment choices, for instance, where to grow such or such culture, where to sell, who to sell to. So strategic decision-making tools are key, and the breakthroughs, the most recent breakthroughs, are going to focus on this area, because we can see that complexity needs to be integrated in investment decisions. We used to have one issue, one solution for crop protection. Now we will have to combine different solutions, and AI will actually be able to include such complexity in the decision-making process. Secondly, perception and vision, computer-assisted vision and perception. In applied research, we have tools on experimental fields that integrate light or heavy tools like the one you have on the picture that actually drive over parcels to acquire massive data. And you need AI to compile and analyze this huge data. It will be important for variety selection. Depending on phenotypes, you need phenotyping data to really select the type of variety you want to experiment on, and then the results. But you also have more lighter data sending information to your smartphone in order to help you come up with a diagnosis. So the AI may be actually within the tool that you already have. You have the robotic aspect. We saw some robots that have onboard AI tools to actually guide the robot in an environment that is evolving, because outdoors, of course, there are different factors. You need safety adaptation, of course, and precision. So there is high-definition GPS data and so on. And you need to have very accurate actions by the robot. So you need huge databases for robots to be able to adapt. Their algorithms are fed with huge sets of data. They need to know all the types of weeds compared and be able to compare them with the plants they're supposed to protect. And of course, generative AI, what we also call natural language. This is ChatGPT and so on that generate texts in its first version. And more you have image and even video generation that use this technology. And of course, this is less useful for agriculture, but it will evolve into more useful functionalities. Now, some real-life illustrations. For example, decision-making tools. More and more, for the past few years, we've seen new decision-making tools that are combined with sensors. I gave the example of FarmStar, but you can also couple with data from weather stations in order to intervene with highly localized data. It can be sensors in the soil, it can be to trigger irrigation or not, or to trigger various climate hazards. And you have more and more connected traps, connected objects, like insect traps to actually monitor bioaggressors and other insects to justify treatments or not, or either in prevention of insects or curative measures. And also technical institutes actually bring together the technical knowledge, and with partnerships with the private sector, they can design the necessary sensors to add to their AI to propose what's necessary for farmers. In the second part of my presentation, I would like to focus on generative AI. This is what we hear about every day. Since November 22, for the past 3 years, the mainstream version or publicly available version of ChatGPT has created a wave of different uses by everyday people, especially generative AI. And people have compared it with the iPhone revolution. And for those who were there when the iPhone was released, specialists did not consider it as innovative because we had BlackBerry phones, phones were already taking pictures, but the innovation was also in terms of marketing. And the fact of having all these functions in one simple-to-use device. And it was not perfect. The first versions were far from perfect. And it was really brave and ambitious to release this tool at such a broad scale. And it was actually, it caught very well. And here on the left-hand side, you can see the number of months that it took ChatGPT to reach 100 million users. It took ChatGPT 2 months. Compared with mainstream platforms like TikTok, Uber, and so on, it took them way longer. And you can see how quick ChatGPT was adopted. I checked this morning where we stand. Right now, we have about 1 billion users. It's difficult to really count, but it's considered that it's going to reach 1 billion users by the end of this year. In 3 years span, it's a huge development. We wished that our own tools were adopted that quickly by users. And it's not only ChatGPT. There are many AI that can generate content. Let's talk about the French version, the Mistral cat, le chat Mistral, which is a sovereign technology, because for everything else, we're talking about technology that come from the US and a few Chinese tools that are being developed as well. So how about these AI? They were called stochastic parrots because they could be a bit stupid. It feels like we put in a lot of intelligence and that all they can do is use huge data and probability assessment to predict a series of words. Like when you write a text message and your telephone tells you what word it thinks is coming next. But this kind of technology, in order to keep it simple, it feels like it's giving the right answer to questions, but if you look closely, it's not always the case. It's always plausible, though, and that is what's disturbing in these kind of tools. I will demonstrate this problem because it is a strong risk, what we call hallucinations, because you can end up telling nonsense without realizing it. This is a heavy slide, but I will comment to explain. This is a very common use, especially in the US. I think it's one of the main use of ChatGPT in the US. It's health advice. People ask ChatGPT why they're sick, what is their disease, and so on. It's really used, and it was shown by a study this year where doctors have looked at the generative AI for diagnosis purposes, and they measured the level of mistakes committed or made by the application. So they tested with Gemini from Google, from ChatGPT, another US very well-developed tool, and 20 to 25%. And these mistakes were actually ranked per level of severity. Sometimes it's not a big deal. Sometimes it can be a very big deal. Sometimes the solution prescribed is actually much worse than doing nothing. And sometimes it could lead to disastrous prescriptions because there are mistakes made. And you cannot forget that it does. Although it is improving, because if you keep up with the news, you can see that ChatGPT is renewing its versions, updating every 2 weeks. So it does correct its tools again and again. Still, they remain imperfect because they're based on databases, and a database can say nonsense. A database can be filled with crap. And this tool is only going to look for satisfaction. They are created to satisfy their users. And if people are happy with the answer that they get, it is ranked well, and that promotes more mistakes on the issue. So in the agricultural field, there are potential uses. You have concrete, tangible examples for variety selection, for instance. Today, such a generative AI is used in selective works to accelerate the generation of genotypes and to come up with models, to have predictive models. So we're talking about predictive genetics. So it opens fields of study that a specialist would maybe have not explored. So it can speed up the selective process. I'd love to do this quiz. We don't have time right now, but when I use this example, it's to show that tools are not always accurate. Although they are pretty efficient, but you know they can be fed images and they can analyze these pictures. And I fooled around with some weed pictures at the very early stage, and I asked these different AI tools to see if they could actually recognize and name the weed. Sometimes the audience makes as many mistakes as the AI, but what's interesting is to focus on the AI results. Here, it's a result that I did recently. ChatGPT told me very plausibly and in a very assertive manner, told me something that was completely wrong because they didn't recognize this weed. Although there are huge databases, but the system is not perfect. And you have more specialized AI that were trained better on more qualified data sets. For PlanteNet, you probably know this tool. It was developed in France by many agricultural technical institutes like INRAE and so on. It's way more accurate for such specialized diagnosis because it was specifically trained for this task. And it is improved, controlled, double-checked by specialists regularly. So typically speaking, you have a result that is interesting because it shows that a specific AI can be better and more efficient than global generative AI like ChatGPT. And because the early development stages are not observed very often by users who could actually add corrections. So ChatGPT users are not that interested in early weeds, so they will not bring in learning capacities to the tool. Now, this is my advertising moment because we have released an ACTA index on the weed flora, and here you have one of our specialists doing trainings. And when we walk around fields with him, we do realize that human expertise has its role to play. So that was just a small anecdote and self-promotion. Now, conclusions, I just wanted to say that generative AI are booming, and they've been booming since November 22. It's a wave of tools. ChatGPT remains the leader on the market, but it has strong competition by serious competitors that do perform very well. But there are also more specialized tools and better performing tools that can be used and that are better for us than these mainstream tools. And keep a critical mind, because these tools keep making mistakes, still do. And fully industrialized uses of this AI is not great. There are many companies working on prototypes to improve, but nothing is good enough to be mainstream and fully industrialized. But it will be a transformative time. It will be a revolution. It will probably take more time than what we think, but it's important to learn about it, to integrate it in our trade, and although while keeping humankind at the core of what we do. Thank you, Mehdi, for your presentation. You understood it was not an AI-generated presentation. We have a few minutes for questions. I have one question. We're starting to talk about the environmental impact of AI. And the agricultural sector has been stigmatized for its impact on the environment as well. How can we manage such paradoxes where tools are used to provide savings, water saving, knowing that these tools do use a lot of water to function, because data centers do use a lot of water to cool down. So how can we assess the cost-benefit analysis of these tools? Very good question, because indeed, major tools such as ChatGPT or Gemini are creating energy demands that are absolutely huge. So GAFAM and other US companies that wanted to have carbon neutrality a few years back have all completely given up and have postponed their objectives forever. And I think the American political context is not helping, because it's not a priority at all for all these carbon neutrality and energy saving and sobriety objectives have been sent, forever in the future. However, this concern of measuring the environmental impact of a technology, servers need to function and so on, maybe using smaller models, maybe using technologies that are different from these huge machines. There are impact measurements that can be carried out. This morning I looked up PlantNet. They assessed that they would have their carbon footprint would be 50 tons of carbon per year. It's the equivalent of 5 French people per year. So some tools are actually trying to evaluate their footprint. I'm thinking also about a startup company that tried to calculate their water savings, because they're using weather stations that are optimizing irrigation to save water from smaller rivers, and they're trying to assess if they have a positive impact in terms of water uses, because they want to go in the right direction in terms of ecological transition.
Oui, bonjour. Moi, je voulais faire la remarque sur l'intelligence artificielle. J'avais une
Regarding AI, I had a question and a comment. Question. When you ask ChatGPT a question, when you use it, you re-implement the database that will be reiterated by robots. That is, today, AI is working on databases created by humans, but in 10 years' time, 15 years' time, I don't know when, databases will be generated by robots themselves. So there is a deviance risk. Deviant risk. Another comment, with those tools, we're talking about the trust economy. We have to trust, because BlaBlaCar works not because it's about car sharing, carpooling, but it's because people trust the driver and the passenger mutually. And they explained that at the head of the company. And I thought that with AI, it's going to create distrust because there's so much false information as well as right information. That's true or false, people don't know anymore. Well, of course, I wondered if there would be a question about the limitations. Yes, I'm putting up this slide because it's what expresses it to me. We have expressed at least 12 limitations or risks by using AI, generative AI, and you've mentioned a few of them. There's the issue of confidential data, private data that we actually give these tools, especially when they're free. You know the saying, if it's free, you're the product. Even with ChatGPT, even if you pay for a paying version, you're still the product because you accept the user's condition of these tools. And they also always say that the data you feed the machine becomes the machine's property. They can reuse it. It's often written as in order to improve the tool and so on. But you can see Google does integrate your navigation story and so on, and uses your personalized answers. If you use ChatGPT, you can actually tick off these boxes, but you really need to look deep in the very small lines of the contracts and so on. You can block the transmission of the data. You can choose not to train the tool with your data. Well, let's hope they actually respect your choice, but you can at least tick the box off. There's also a major risk. Well, there are data that can escape. Some companies do not want their employees to use AI unless it's been vetted by the company. And you also mentioned the problem of fake news. We will see the rise of an improvement. Very recently, the very last models of Gemini that were released last week or 2 weeks ago, it's impossible to make the difference between real life video and AI-generated video. It's a real source for concern. Either people will overtrust even fake news, or they will actually not trust anything they see anymore. And it will create issues in terms of information availability and access to information. Also, these tools are fed from internet-based databases, but more and more they will learn to start from their own artificial content. And we can observe a degrading. It's like the photocopies, you know, if you photocopy an original, if you photocopy the photocopy and then you photocopy the photocopy of the photocopy, then you've got an image that's completely blurred. And some studies have shown that the quality can degrade. The algorithms can learn from lower quality of data as the copy goes. And so it's another issue. Additional question, if we imagine the agriculture sector in 2030, 2050 with more robots, more AI, can we actually have an idea of what it's going to be like? What will farmers' jobs will be like? What training for tomorrow's farmers in that world? Well, training is absolutely key. Some farming schools actually already take that into account. I think you can't stop progress, so we have to adapt. We have to train ourselves. This is what we think anyway. We need to make these tools our own in order to be able to be critical, to have an opinion, and understand what use is necessary and useful and what is not. And even in 1 year's time, it's difficult to imagine what it's going to be like, because it goes so fast and the acceleration is exponential. So it's very difficult to know where we're going to stand in 5 years' time. You can see the dependency, I can see this slide, there's also a problem of addiction, an addiction creation when using these tools massively, a lack of sovereignty, a lack of autonomy at the national and European level, because these technologies are not ours. And we may become addicted to US solutions. So it's another issue to be taken into account.